Okay, hello everyone. In this video, we will do some calculations on evaluating some interesting integrals, okay, and some techniques will be covered. Um, Today, we will talk about this integral, okay, integrate from 0 to pi over 2, and then log of sine theta, d theta, okay. But before we talk about this integral, okay, we will get two tricks, okay, which will facilitate our evaluations. Okay, the first one will be for some function. Okay, we will call f of theta, f of sine theta. Okay, and then if we integrate from 0 to pi over 2, okay, and then d theta, okay, which will be equals to, we just change sine theta into cosine theta. Okay, for any well-behaved function. Okay. Well, why is that? Okay, it is easy. Okay, because we do a simple substitution. Okay, for example, we let u is pi over 2 minus theta, and then in that case du will be minus d theta. Now when theta is equal to 0, we have pi over 2 here, and then when theta is pi over 2, we have 0 here, and then f sine of pi over 2 minus u, and then d theta will become du to minus 1. And then the minus sign here can be absorbed into the interval, okay, but we flip it, okay, flip it. So we go back from 0 to pi over 2, and then we notice that this one is just a cosine u, okay, cosine u. So we have this one, but of course, for a definite interval, u here is just a dummy variable, so we can please to change to theta, okay. So we get back this result, okay. This is our first tools here. Okay, now how about instead of from 0 to pi over 2, okay, what will we get? Okay, what will we get if we change from 0 to pi? Okay, so we want to know, can we further simplify this one? Okay, okay, we don't know this one yet, okay, but we can try. How about we split the interval from 0 to pi to 0 to pi over 2, okay, and then f of sine theta, d theta, and then plus, okay, f of sine theta. This one is just the previous one, okay, this one, okay, so we probably keep it. And then for this one, okay, we may change the integrating interval, okay, to the same, okay. How to do that? Okay, we all observe that this is pi over 2, this is pi, so it would be better, okay, if pi over 2 change to 0, okay. So the best way is to subtract it, okay, so we make a substitution here, that u is equals to pi over pi minus theta, okay, pi minus theta. In that case, when theta is equal to pi over 2, u become pi over 2, okay. Sorry, what I say. Okay, when theta is pi over 2, u is become pi over 2, okay. When theta is pi, okay, then u will become 0, okay, and then this will become f of sine, and then pi plus u, sorry, pi minus u, and then we have du here, and then with the minus signs here. So this one will become f of pi minus u will become sine u. So altogether, what we get is 2. So basically, this is a very nice property, okay? Okay, so for integration of some function with sine theta as an argument, okay, from 0 to pi, we just simply chop it into two parts, okay. It's just 2 times 0 to pi over 2, same integrand, okay. Okay, now with these two tricks in hand, okay, we can now attack this problem very easily, okay. Okay, so now we let our target I to become 0 to pi over 2 and then log of sine theta d theta. Okay, the first tricks, okay, tells us that we can change sine theta to cosine theta, okay, for some function, okay. Here, the function, we say fu is just the log u, okay. So, we are free to change it to log of cosine theta, okay, by our first tricks, okay. Of course, this is not useful, okay. We just know that these two integral are the same, okay. Now, for the second one, okay, what if we use 2i, okay? 2i is I plus I, okay? And then for the first I, we use the first one. For the second I, we use the second one, okay? That will become 0 to power over 2 and then log, and then sine theta plus log of cosine theta, and then d theta. And then for the log functions, addition of log is just a product inside, okay? So log and then sine theta times cosine theta and then d theta. Now, we recall sine 2 theta is just 2 sine theta cosine theta. This is the double angle formula, okay? Double angle formula for sine. So we notice that it is very similar. So we want to add a 2 here, okay? Add a 2 here. But we have to cancel these 2, okay? So basically we divide this by 2. So for the log division is just subtractions, okay? So we subtract log 2 here. So 2i is equals to log of sine 2 theta and then d theta. And then for the second one, second integral is just a constant, okay? So basically it's log 2 and then 0 to pi over 2 and then d theta. Of course, this is easy, okay? This is just pi over 2, okay? Now, we see a 2 theta here. So, we perform another substitution, okay? Which is easy, okay? We want this sine 2 theta to become theta, okay? So, the obvious way is to let u equals to 2 theta and then du will be 2 d theta, okay? So, when theta is equal to 0, u is 0, and here is become pi, and then log of sine u, and then d theta will become half du, okay? Half du. So what we have now is 1/2 0 to pi log sine of u du, and then minus pi over 2 log 2. Okay, this one, which is obvious, our second trick, okay? This is a function of sine, okay? Which is log, okay? The fu is log u, okay? We just plug in u equals to sine theta, sine u, okay? And then for 0 to pi, we know that it is just 2 times the original integral, but half the interval, okay? And then, okay, we just write down, okay, like this. And then this will be cancelled. And we just recovered back, this is just I, okay? And then what we have is 2i is equals to I minus pi over 2 log 2. And then we subtract the I. So what we have is I is equals to what we have here will be, will be 0 to pi over 2 log of sine theta d theta actually equals to log of cosine theta and minus pi over 2 log of 2. Okay, this is the result we have, okay, using two simple tricks. Of course, there is a one bonus integrals here. It's just if we subtract these two integrals, okay, of course, because they are the same, so their integrals will be 0. So what we have will be log of tangent theta d theta is actually 0. This is a bonus. Of course, we can do some another substitution here to convert into another representations, okay? But it will be in next video maybe, okay? So that's it, okay? Easy method to compute, a little bit interesting integral, okay? Maybe in the future, okay, I will make a videos on how to evaluate the same integral, okay, but with the interval different, okay? So maybe say from 0 to pi over 4, okay? What will be the answer? Okay, thank you. Bye bye.